Hi, good evening. I have done a project about predicting breast cancer based on optimized deep learning techniques. Let's see the project objective. Breast cancer is one of the most prevalent and potentially life threatening disease affecting women worldwide. Early detection is Early detection and accurate diagnosis play a critical role in improving survival rates and treatment outcome. Deep learning and techniques can improve breast cancer detection in results in various medical applications, including breast cancer production. This project aimed to develop a optimized deep learning model for predicting breast cancer and advanced technique to improve accuracy and reduce false positive and negativities. Next, we will see the project methodologies. In this, we will focusing on developing a optimized deep learning techniques that improves breast cancer prediction accuracy. We will be utilizing a data set consist of 250,000 mount slide images of breast cancer, and we will clean and sanitize the data and then process the data pre-process the data to perform data partition and handle mismatching data and creating training and testing sets data sets and build a classifier and fit the data into a model selection and then hyperparameter trending and then check the accuracy of model and measure it efficiently. Next, we will see the data collection. In data collection, we will take the breast cancer images from different websites like MIAS website and BCSC website and Kaggle website. In MIAS website, we will that is Mammography Image Analysis Society. In this images in this website, we can take different breast cancer images and breast cancer surveillance consortium. In this website, we will take some mammographic and bioscopic images and breast histopathology images from Kaggle. I have used Kaggle website only. I have downloaded the dataset from Kaggle website, which is a popular platform for data scientists and machine learning enthusiasts for setting data. So once we log in into Kaggle, we choose some data set that was relevant to our breast cancer analysis and objectives. So once the data set was downloaded, I have uploaded in the Google Column platform and started my data processing steps. Next, we will see the data pre-processing. In data pre-processing, it is a critical step in data analysis and machine learning projects. It involves transforming data into a format that is suitable for analysis and modeling, removing duplicates and handling incomplete data, cleaning the data by removing any irrelevant or inconsistent information such as duplicate record or incorrect values. This step helps to ensure the quality and reliability of the data. And next, we will standardize the data format. When working with image data into data analyst task, it is often necessary to convert images to standardized format to ensure consistency and compatibility across different images. Next, normalizing and scaling the data. Normalizing and scaling the data are a techniques used to transform numerical data to a common scale or distribution. Next, we will see the live demo of deep learning algorithms. Here, we will see these three stages. One is data pre-processing stages. Next one is CNN algorithm and evaluation. And next is final model and output. In data pre-processing stage, we will set the training set and testing set, training and testing this data set. And in CNN algorithm, we will run some algorithms, and finally we will get some outputs there. Uh, let's see the code. Uh, in Google Colab, I have uploaded the dataset in Google Colab using Google Drive import. I have imported my project here, and I have imported the zip file also. Uh, and I have given my zip folder here. I have given my path also here, and then I have imported required libraries which we will use in Python, like pandas, nami, matplotlib, keros, these and globe random, these and all I have imported here. I will explain that in another steps. Pandas stands for Python Data Analysis Library, which is a popular Python library that is mainly used for data processing purpose, like cleaning and manipulating and analyzing the data. And then matplotlib, which is used to uh, create a bar chart, pie chart, bar chart, pie chart. These and all we will use this matplotlib live. And then I have some breast cancer images which I have stored in my drive, like this path. I have given the path here, which will store in breast underscore image. I will show my images also. I have given the path here, temp breast cancer CNN, and then breast cancer data set, there IDC regular. Here we have many breast cancer image folder. Breast cancer image folders are there. In this folder, we will have 0 and 1. 0 indicates negative breast cancer, and 1 indicates positive breast cancer image. When I open this image, it will show many images like this. Like this, we have many images here. So only we have used this star underscore star slash, which will show many. It has many breast cancer images. Uh, the this globe command, which is a function that is used to search for a file that matches a specific file pattern or name. uh, if we have like breast cancer image 0 means, that means no breast cancer, that image will print. Next, segregating image based on positive and negative breast cancer images. N underscore IDC means negative breast cancer, and P underscore IDC is positive breast cancer. I have given an in for loop. If it is 0 means it will print negative breast cancer image. If it is 1 means it will print positive breast cancer image. Next, we will see the data visualization using Matplot library. Here I have used different plot commands. I will explain it. First, plot dot library. This this command is used to set the size of a plot in Matplotlib. Is a popular Python library used for data visualization. This command is a helpful tool to optimize the size of your plot and improves the visual representation of your data. Next, we will see the np.random brand int 0 comma length n underscore idc comma 18. This command, the it will generate a nummy array of 18 random integer number within a array of 0 within a array of 0 and length of the n underscore idc list. This random is a submodel of NumMy that that contains function for generating random numbers. Randint. Randint uh, is a function that generates random integer within a given array. Next, we will see the this command. This command loads an image file that the specified path and resize it to a fixed size, which can be used as input to machine learning module. And plot dot plot.subplot, it is very useful function for creating and arranging multiple subplot within a single figure. And this axis of this function uh, is from matplotlib library. Um it accept uh, this module that turn off the access line and label in a plot. And plot dot Title. It is used to add a title to a plot, and it accept a string argument that specifies the text to be displayed as a title. Next, next plot im plot.im show. This function is useful to display 2D arrays and images, and it accepts a dummy array or a PIL image instance as a argument. This img.as as type. This method is used to convert the data type of the array to 8-bit unassigned integer format, which is common format for image data. While running this, we will get this output. This is the no cancer and negative and positive cancer images. Next, we will see the process image using OpenCV, uh, cv2.im read. This function is used for this function is from OpenCV library that is used to read an image from a library, and this im read color. This is a flag that tells OpenCV to read the image color mode color mode, and CV2 resize. This is a method used in OpenCV for resizing the image, and it allows us to adjust the size of the image to a specified width and height. The method can also be used to scale images up and down, and it supports multiple interpolation method for resizing the image, and this append method is a built-in Python function. It is used to add a new element to the end of the list. Next, we will see this slicing data image. Can underscore image underscore array 2 will contain the first 500 50,000 elements, and elements of can underscore img underscore array. This slicing operation can be useful when working with large amount of data set, as it enables us to work with smaller subsets of your data at a time. Next, we are going to see the shuffling uh, dataset image. Here we are going to shuffling the dataset image. This np.concatenate function is used to join two or more arrays along a specified axis. It is concatenating the non underscore image underscore array 2 and can underscore image underscore array 2 uh, arrays along the first axis, which is in vertical axis. This random dot shuffle function takes a sequence and shuffle its element randomly. Next, we are going to see visualizing the data using bar chart and pie chart. Uh, here, uh, here we have using a bar chart and pie chart commands, After running this, we will get this pie chart and a bar chart with title. And next we are going to see the train data. Here we have train data. Here I have imported here I have imported uh, TensorFlow dot keras dot and util import to categorical. It is to import categorical function from the keras.util module. This function is commonly used to convert class vector to binary class matrix. Uh, this two categorical of function takes an array or a list of integer as input and returns a matrix with where each row correspond to one of the input integer and each column correspond to possible values of a categorical variables. After running this, we will get this output. Next, we are going to see the reducing reduce the training and testing dataset for faster processing. In this comments, in this code, it is reducing the size of the data x train, y train, x test, and y test by keeping only the specified number of element at the beginning of each data set. The purpose of this code is to create smaller training and testing set for faster processing or to work with a limited amount of data for experimentation or some debug purpose. Next, we are going to see we are we are importing some optimizer matrix and callbacks and functions. We are importing this this first line of code is used to this line imports the Adam and SGD optimizer from the TensorFlow and are commonly used in training deep learning models and to update the model's parameter during the learning purpose. And next, the this line of next line of code is used to import the binary cross entropy matrix from the dot matrix module, and it is a common loose function used in binary classification program. And next command uh, is used to import the early stopping callback from a tenant's flow that stops the training purpose yearly if certain criteria such as the validation loss not improving for a specified number of echoes or met. And confusion underscore matrix, this will import the confusion underscore matrix function from uh, S- sklearn, which is used to compute the confusion matrix. It is a useful tool for evaluating the performance of a classification model. And at last, we are importing ITER tool. Uh, which will provide various function for efficient iteration and combinations of iterables. By using this by importing these line of code, we will classifying the images into different layers and output classes. uh, these line of code will which these line of code defines uh, CNN model with multiple pooling, batch normalization, and dropout and dense layer, and it is designed for image classification task with input images of size 50 into 50 pixel, and 50 into 50 pixel, and three color cha- channels. And the model architecture aims to extract features from the input images and classify them into one of the two output classes using a softmax activation. And yearly stopping callback is also defined to uh, de- defined to monitor the validation loss and stop training if the loss does not improve for a certain number of echoes. And then we will compile the defined model. We will combine the defined model. While compiling this model with the specified optimizer, loss function, and evaluation matrix, the model is prepared for training with a specified optimizer, loss function, and evaluation matrix. This step is necessary before starting the actual training process. And then we are initiating a training process. This model dot fit function starts the uh, training process with the specified setting. It will iterate over the training data for the specified number of echoes, optimizing the model's weight using the defined loss function and optimizer. And then the validation data will be used to evaluate the model's performance during training. The training purpose, progress, and metrics will be stored in a history variable. After that, this echo equal to 1. This argument determines the number of times the entire training set it will iterate over during the training process. Here it is set to 1 means the module will be trained for 1 echoes. If for example, I'm giving 10 means uh, the model will be trained for 10 echoes. After that, model dot save, we are saving the trained model. This line saves the model to a file name, uh, new breast cancer dot h5 in the current directory. The file format used in uh, hierarchical data format, which is commonly used file for storing large amount of numerical data. By saving the model, we can later load it or use it for further training without having to retrain the model from scratch. After that, we are importing the module for loading a trained model. This code will this code will import the necessary model for loading a pre-trained model, working with image and manipulating the arrays. After that, uh, we are loading the saved model from file, which is located at the specified path, and assign it to the variable module. It is used to load a saved model from a file. And we can load an image. Next, we can load an image class 1 to the test model. Here we are loading the class 1 to the test model. Uh, and then in this command, we use the model to make prediction. In this code, we are converting the loaded image into nummy array and expand its dimension, and uses the pre-trained model to make a prediction. Now the prediction for the input image stored in a predict variable, which can be further purpose or analyzed as needed. Uh, Here we have given class 1, means it will display the positive cancer image. Here here it is displaying the result class 1 for positive scenario. The output is 1. And the same, like we are loading the load an image class 0 to test the model. After that, we are using the model to make prediction here, and then prediction here, and then we are displaying the result class 0 for negative scenarios. And we are going back to the slide. Future work. It is used to increase the accuracy and reliability of the model, and it is more efficient to use for the patients also. And it is used to increase accessibility and easy of use for patients and medical professionals also. In future, while uploading these images, we will get the result at a time. In conclusion, optimized deep learning techniques offers a uh, predicting breast cancer with high accuracy and efficiency. By uh, the power of a deep neural network, these models can efficiently learn from complex medical images and provide valuable insights for diagnosis and treatment planning. However, further research collaboration and ethical consideration are necessary to overcome challenges and maximize the benefits of optimized deep learning in the field of breast cancer predictions. Thank you.